My name is Lorenzo Mangani. I'm from the SIPCAPTURE project, or Homer, as many know it. And today, just going to give you a little bit of a recap of the project. So first part of the presentation, for those of you who are already familiar with Homer, might be a little bit redundant, but there's something in for everyone. So down the presentation, we'll get into where we're at and where we're going with the project. So without further hesitation, what is Homer all about? Homer is really born with the best intention of making the troubleshooting life of voice engineers easier. I was one, and I'm still one, but when I started working on the project, that was our main purpose. We just wanted a way that wasn't expensive or didn't cost our company $1 million to do monitoring better and to be more flexible. So whether you operate a hosted PBX, a class 4, class 5 soft switch, or you're building the next RTC service, monitoring the signaling, your service altogether can be a quite tedious task. And of course, the more you scale, the worse it gets. So there's multiple steps involved typically with the process. So you start, of course, with a problem. If you're lucky, you already know the problem. To get to the troubleshooting part, your guys, your support team, they need to identify the systems involved. They need to figure who the subscriber was. They need to perform call traces. They need to figure out how to correlate those with other logs, other systems, other legs even of your systems. Get anything else that's related, pack it up, export it, share it with their colleagues or whoever they need to make it easier. So a nightmare, unless you use Homer. And let's see how. So Homer is a scalable and distributed capture and monitoring system. Its purpose has changed and has evolved multiple times over the years. We started as a simple centralized collector for SIP only. And over time, we kept expanding it to be able to deal also with media, logs, now other protocols, WebRTC, you name it. So we try to make it a centralized collector for real-time communications. Whatever the protocol that you want to use, whatever protocol that you're already using or will be using, Homer tries to get in a way to make your life easier. So what does it do? It provides you with a centralized location where you can store and, of course, find and filter your packets, your sessions, your flows, however you want to call them. So normally, your systems are going to have multiple legs going across from your switch, back-to-back user agents, services, voicemail, whatever it is. You can send all of those legs into Homer, configure it so that it can know how your network correlates, and it just brings them all together for you. So to have we call it a real-time communication time machine. So it allows you to just look at whatever is happening right now or has happened in the past. It features, of course, a lot of tools, mostly focused on visualizing and making it easier for people to troubleshoot those sessions. It features automatic correlation of legs, so you can, as we said, teach Homer how you're forking on your system so that it can follow the same logic. And it supports also logs, quality reports. It produces a lot of statistics. And it offers you a few ways to drill down on your sessions and your protocol. The core of Homer is based either on Kamailio or OpenSIPS, so it sort of inherits all of their flexibility. Homer is based on our module, which is called SIPCAPTURE module, but it can interact with just about anything else on Kamailio or OpenSIPS. So you can mix and match it with whatever you want, meaning that you can attach it to different data sources, you can feed it more data, and so on and so forth. It's made of two sides, so we have capture agents, which you can have one or multiple, and then we have a capture server, which typically collects everything. Last but not least, you can also export it in standard format. So if you want to make a PCAP out of whatever you capture in Homer, you can. Mind, we don't store PCAP, so our system is not like others, so we don't need to record everything to disk and then figure out what it did afterwards. We do everything in real time, and we only store the minimum amount of packets that we can to do the job. Also to be, sort of privacy friendly when this is useful. So the project started around 2011. As we said, we were a SIP-only application with literally almost no user interface. Over time, our grew and our ideas grew. So we added exactly charts, statistics, display. We changed completely the user interface to be modular and extensible. We started adding more protocols. We started integrating with popular RTC gateways and whatever modern communication requires. So we try to go with the market. We're usually not ahead of it, but we try to be in real time in sync. Currently, we're on Homer Cloud, which is a little bit of an extension of our concept, where we do split the troubleshooting part of our application from the analytics or the business analytics side of it, which is very interesting. And we'll see this down the presentation. So, as we said, Homer is based on Kamailio OpenSIPS for the car. So we have our own module for both platforms, same name, slightly different configuration, but very similar features, which we use to basically turn a Kamailio OpenSIPS instance into a capture server. The same applies for pretty much all of the other components of our solution. So you can choose exactly how to build your capture server. You can choose your core database based on your preferences or your skill set. By default, we use MySQL 5.7 and InnoDB with Homer, but since last year, we have full compatibility also with Postgres. So if that's your thing, you can join us, and we need more users to make it even better. So that's awesome. For statistics, we support exporting everything to Elasticsearch, InfluxDB, and Graylog currently. It's very easy to add more, so whatever you use, you can plug in. And the web server part, which is just used really to serve the API, and the user interface of Homer can be served by Apache or Nginx, depending on your preference. So it's all about options. We want users to be able to recycle their skills. We want you to be comfortable with the solution just as much as you are with the soft switch or the proxies that you use or that you want to monitor using Homer. So it's all about choice, and we'll see some of those. Typically, as we said, we serve using our Kamailio OpenSIPS, Apache, and MySQL. But again, this can be changed, and we'll see how you can tap some of those options. So it's awesome, but how do we get data into Homer? So we know we have this centralized collector. How does it get our packets? It's a little bit of a breakdown with very crappy resolution, and apologies, of our ecosystem. So at the core, you see capture servers. Those are the elements that you can use to create the collector. So either Kamailio, OpenSIPS, or pCapture, which is our own engine, which does a few advanced things in real time, but we'll keep it out for now. And on the other side, we have the capture agent ecosystem. So the capture agent can be either a full-fledged application. So we have, for instance, capt agent, SIPCAPTURE, SNGREP, which are all, let's say, capture tools, which do feature support for the HEP or EEP encapsulation protocol, which is the protocol that we designed and we use to mirror packets from the source to our capture server without losing any of their details. We can also add additional stuff onto the header, so it's a flexible encapsulation format that luckily has been adopted by many of these platforms. So inside of Asterisk, FreeSwitch, OpenSIPS, Kamailio, and RTP engine, you have a native HEP capture agent. So with a simple option, by enabling the support for the protocol and the configuration as of where you want to send this data, you have native support for Homer. So this is a quite significant difference, because it means that you don't have to reinvent the wheel, install additional elements, or really do anything different from what you're already doing. You just choose what you want to mirror and you send it. In case you cannot be covered by one of the solutions or you need to make your own, our GitHub repository offers a bunch of code for implementing HEP in your own application. So I use Java, Python, Erlang, C, C++, Go, Node, and there's more. It's very easy, or almost as simple as copy-pasting a few functions to have HEP support. So you can use this in just about anything you want to interface with Homer. At the bottom, we also see the RTC and gateways, let's call them what they are, that we currently support. So Janus, which I think almost everybody will be familiar with, RTC Engine, which is a product of Deutsche Telekom and Zipwise, and Spider from Jamben are three platforms that we already support. But the way we support them is very agnostic. So we sort of have an abstract protocol that we just map to either of those setups. As you know, WebRTC is not really something that's defined or set in stone. It's a very fast-changing picture. And we just created an abstract model that you can use to map whatever you're using to realize your RTC sessions into Homer and correlate it with everything else. As we said, many platforms do have native support for doing the mirroring. So we're Asterisk on, so we'll talk just briefly about how Asterisk does it. So by default, since version 12, Asterisk ships with the REST-HEP and REST-HEP RTCP modules, which are native modules with the task of exactly grabbing anything that your box is doing and mirroring to a collector for troubleshooting, investigation, analytics, and so on and so forth. We can do this for the SIP protocol when using PJSIP, and we also do this with RTCP packets. So we can also monitor how the media relay is doing, how it's reporting, packet loss and everything else, stream it directly to Homer, and when you open the session there, we'll see, you can sort of see it all come together. The same applies to FreeSwitch, OpenSIPS, Kamailio, and RTP engine. It's as simple as configuring a couple of options to have native support and nothing else installed on the box. As you can see, also for Asterisk, it's literally 2 options that you need and 2 are optional. So you just enable the support, you set the capture, server address and port, and optionally a password and an ID where you have multiple boxes, you want to be able to tell which one of them was sending what. So this is a way to identify them. So keeping it simple. If you do not have one of those platforms and you still need to do the job, we also ship Capt Agent. Capt Agent is a universal agnostic capture agent that we developed over the years. It's also the flagship integration of the HEP protocol. So this is the agent that really features it all, and it has all of the capabilities that we developed for the protocol. It's modular, so it can do multiple things. You can load it just with the basic setup, or you can also have it do RTCP mirroring, RTP with some extended modules that we provide, and so on and so forth. It supports multiple input, processing, and output, just like a Logstash or any other modern application with pipelines. So you can support multiple capture protocols, multiple capture technologies, just plain PCAP, or maybe PF ring, RX ring, and so on and so forth. You can pass it through any processor. So currently we have universal modules for signaling, media tracking, but it can very easily be extended, and then output module. So we can send it out currently in either HEP, our protocol, to Homer, or as a JSON object. So everything can be turned into a JSON object and sent wherever you want to track it. If you just want to do it quickly, SIPRep and SNgrep are 2 very commonly installed CLI tools, which you can use to just make quick console troubleshooting, and both of them support also forking to Homer. So whatever you're doing in the console, you don't have to remember. You can just have the application mirror it at the same time to your collector, and anybody else in your team or yourself later on that day can make use of it and keep it. So the point, you get it, is just making it easy for you to mirror. We also talk about logs. So this is, Homer is not at all about SIP protocol anymore, as it was in the past. Today supports many other features. One that was very much requested by all of our users was the ability to sync application logs with the signaling sessions. It's quite, it's simpler to say than do, but your systems, as they handle calls, will produce a bunch of logs. A lot of those are going to be almost meaningless most of the times, unless something is going wrong. Then you need all of it, and you need it quick, and you need it to correlate. So this is what we did. You can do it either with HEPpipe, which is our own node application, quick, flexible, low cost on the system. You can just point it at any log, give it a key or a regex code to extract a correlation ID, and this is the only important part. We need to correlate those log lines with SIP sessions. So typically you would have a, Kamailio log or an OpenSIPS log, include the ID, so the call ID that this log reports for, and you can just grab all of those lines, ship them to Homer, and Homer will automatically correlate them. So when you open a SIP session, basically Homer will put together all of the legs that you have, all of the media reports that you received, and all of the logs that match any of the correlation IDs that you're handling. So we just try to make it, a one-click experience to see everything about a session, including what the systems did as it was flowing. You can also do it with Node Logstash, which is a Node version or reintegration of Logstash supporting Grok. So very flexible. You can just tap just about anything you want and send it to our system. So now that we know how we get data into Homer, let's see how it looks or how we use it. So by default, Homer is basically an abstract environment where you have widgets. Those widgets can either take care of displaying data or searching data, mostly. So the two main categories are exactly charting and forms to define what you're looking for. Everything is done in Angular in the new version, Homer 5, so it's very easy just to grab an existing widget and create a new one. You just fork it, map it to whatever you want to use, and off you go. The main purpose, of course, is letting the user search and filter for all of the messages and sessions that we have collected. So whatever has been sent to the system and is within data rotation is immediately available. Display and filter this data in real time. So if you're doing any kind of real-time activity or monitoring something, you can use Homer with strict search details and refreshing display to just track something or the evolution of some traffic in real time. You can visualize everything. So we have a bunch of tools. D3 and Float is what survived. We also had others which we decided to drop for low usage. And of course, last but not least, export and share the investigation or the results of the investigation with a third party. This could be your customer, to justify or to explain what happened to their service. It could be your peering partner to display or prove that there is an issue that they need to be working on, and so on and so forth. When doing troubleshooting with Homer is simple, so we try to keep it simple. It doesn't feature 100,000 buttons and functionality. We just want you to be able to search, find, and get together all of the data. So as we said, we can put legs back together. Here you see a little example. Again, I apologize about the quality. I don't know why it's such low-fi, but you get your results in a table. You can click and inspect each and every single message, or you can just see the session. As you see, Homer just puts all the legs together and displays the flow between hosts. Automatically supports any number of hops, so you can just keep going and going. We said we support logs, so we have a tab for those sessions where you can see exactly what the system handling that call was doing. So in this case, we see some channel information from FreeSwitch, I think. So you can see exactly what the decisions the system was making or how a dial plan was evolving, received input, DTMF, whatever you want to collect, you can send it here as an abstract row. Media. So we keep hearing a lot of people are convinced that Homer does not do media, that it's only for signaling, but that is not the case, and it hasn't been the case for quite some time now. So Homer is able and well able to deal with session statistics. So we have agents which take care of doing analytics for RTP or RTCP. Homer can also do RTCP directly, but it can be a little bit expensive in terms of inserts if you just send everything to it. So we have some agents which do pre-aggregation of all of your media statistics, and we send them to Homer in a, let's say, synthetic form. And Homer is, as per everything else, able to present it. So here you can see a screenshot where we see for an RTP session exactly the breakdown of the packet loss, the jitter. We calculate the MOS, and we display everything on a chart for what this session was doing. So here's a little more of a zoom in. The same is also possible with XMP RTP stats, so user agent generated reports, or RTCP XR reports. So if your agents or enterprise phones and so on are able to report on their quality by themselves, Homer can be a collector for those. So you don't need any third-party application from one of those vendors to just make sense of them. You can just send those reports directly into Homer or into a system that is monitored by Homer, and the system will just automatically figure it out. So the typical case here is the publish messages for the RTCP XR, which deliver either periodically or at the end of the call all of the statistics about the media quality. And we just display it out for you. So you can see exactly with as much granularity as the agent was reporting what was happening. So even if there was a small gap or a loss anywhere in the path, you would notice it. What Homer does as well is overlap many of those reports. So you can at the same time have a capture agent monitor RTP from the network, and you can have the user agent report. So you can very easily overlap what the experience was on your network versus at the customer location. So we know directly from their device if this session was sucking or not. So that's pretty much unreplaceable. If you really want to know what the customer experience was, trust their device. So that's a little bit the default, or what Homer already does, or what many of you maybe already knew. So let's see what's up. what's next with the project. So we talk about statistics. So while you do all of your troubleshooting and you're able to drill down, find your sessions, see what the agents were doing for invites, registrations, and so on, of course, the system produces a broad scope of statistics. Normally, those statistics are saved on the same database that you're using for storing signaling and everything else. So it's a sort of an all-in-one approach. This has advantages for small and medium operators because they don't have to worry about too many moving parts. So you just have a system, and that's your monitoring system. It's standalone, it rotates its data, and you don't have to worry about anything other than sending it packets. This works for most people. So as we said, the pro is that you don't have many moving parts, but the con is that you share those resources. So there's a point where inserting so many packets, creating so many statistics, and having maybe a team of 20 support agents querying them at the same time gets into a bottleneck. So you would get something like this: request timeout when and we see people. I mean, support engineers, when you feed them a tool like Homer, they're just going to go and use it. They're not going to say, is there any rule? Should I not do something? They will just go and click whatever is available. So a lot of them will go and say, hey, let me see the statistics for the last 6 months. That's going to be cool to see what my network was doing. And not realizing that, spawning that kind of query onto the system that's capturing the data, maybe already at a certain capacity, can literally kill it. So how do we solve it? This is a big data challenge. So what we did, as per always, we went and we leveraged all of the beautiful things that the platforms that we build Homer with already do. In this case, OpenSIPS and Kamailio both have very powerful REST agents. So we just went ahead and we used those. And we decided to take all of the statistics that we were saving into Homer, into let's say the local storage, so either MySQL or Postgres, and ship them out to one or multiple collectors. So we started with Elasticsearch and InfluxDB recently. In the last couple of weeks, one of our contributors added support for Graylog as well. What does this do? So in the Kamailio or the OpenSIPS dial plan, you can create your statistics. So Homer is not a box product or something that you just have to accept how it is. It's a framework that you can use to create your own monitoring solution to do what you need. So what you can do now is exactly in OpenSIPS and Kamailio, create and track any number of statistics that you want and ship them out to a much more powerful, of course, or independent, let's say, data collector. So in our example, and we have a good demo at our booth that you can come and see and play with at any time, we use Elasticsearch. We send basically everything there. We send all of the statistics that we generate. We send CDR-like entries. And what we do is basically create the environment that those users wanted. So this is a place where you can go and you can look at a year's worth of statistics without impacting your core, and a place, of course, where you can do much more advanced aggregations and much more complex queries can take form. So, if you have questions like, how many of my users are, or how is the usage of my infrastructure distributed across my paying subscribers. With a tool like this, we can actually achieve that. So we can create grouping and tagging for traffic in a way that was almost impossible to do with Homer standalone, and exactly provide you with an additional way to create advanced analytics and business intelligence. Of course, all of this would be useless if you had to look at it by hand. So we also came up with Kai, which is an extension or an app actually for Kibana, which takes care of watching data. It's a little bit of let's call it an open reintegration of the Elasticsearch Watcher, or something like Capacitor, which you can use to look at those statistics that you have generated and set actions, alarms, and triggers for all of those. So if you, for instance, you're monitoring MOS quality, or maybe call duration, call completion, the number of messages that you have, if this data changes in any way that you think is meaningful and you should be alarmed for, you can just set a watcher. So make a query, basically, copy-paste it here, decide what the action would be. So, if I'm looking at, I don't know, last 1 hour of traffic and I want to know if it changed in a proportion from the hour before, or the week before, or the month before, or from Christmas Day, I don't know. Whatever you want to check against, you can. You can set an alarm, you can distribute it to whoever you want, and keep your team aware of what's coming, basically. So we try to exactly create new tools. It's not something that you just have to accept. It's tools, it's a framework that you can use to create your own monitoring solution based on what your business requires. Installing all of this is pretty easy nowadays. It used to be a little bit of a nightmare. Today we have more decent ways to do it. So we have a classic, always green bash installer. So if you just have a bare system and you want to have Homer running in a few minutes, you can just run our bash installer. It will automatically detect the OS and the support for it, download the packages, get everything up and running, and off you go. If you use Docker, and more people do, we have pretty good single and multi-container setups that you can just fetch from Docker Hub and run immediately. They're production ready. A lot of people are using them. Of course, it makes sense if you're monitoring a Docker infrastructure to use it. And last but not least, Puppet. So Giacomo from our team created very good recipes that you can find on our repository. So if that's your thing, that's another easy way. If none of the above is the case, you can always contact our team and we'll help you figure the best way to do this or to get Homer installed. Yeah, that's pretty much all about Homer. If you guys have questions or maybe some topics that you would like to drill down into, I think we still have some time and we can take advantage of that. Or if you want to go back into any part of the presentation and drill deeper, I try to keep it open.
When you're going the big data route, do you still need to have a MySQL or /PostgreSQL database?
Yes, we do use it. We continue using it for signaling right now. This is something that we'll also test and migrate as we get users willing to walk that path. But right now, the idea if you use this is that you ship everything that's a statistic off the system, and we only keep the signaling on board, and maybe do user authentication unless you do use something centralized like Radius or LDAP. So what you would have left on your MySQL or Postgres would be the messages that you're collecting and the authentication part. All of the logs and stuff, you can now send them to the external collector. And the Homer interface, I didn't go a lot in depth of that, but the call setup, the call session details can fetch now also from InfluxDB and Elasticsearch. So we can look for all of the signaling, all of the logs either locally or remotely, and just merge it back into a single view. But the signaling is still on board. So
The messages are going to be in MySQL and everything else?
correct. Everything else can be forked off board.
Yeah, so I've been using Homer for many, many years, 3.x. When I tested the 5.0, one of the things that was kind of particular was the time zone setting and all of my SIP logs. So I was in, for instance, I was in -6 time zone.
Yes.
But the actual database
UTC. It's UTC, I think, or by default, unless you change it. All of the data that we collect in the database is UTC. I think it's now probably 4 or 5 months ago, we added to the time selector also time zone. So you can now choose in which time zone you want to see statistics or you want to do a search starting from UTC. So if your agent is looking at the same traffic from Europe or from the US, they can now choose where they are located and make sense of the traffic. So this is something that probably it wasn't there when you tested it, or?
Yeah, no, it was there when I tested it, because I've been going back and forth getting the latest Git, but the problem I was running into is when I select time zone, it was an hour off.
It was an hour off.
So instead of being, so if I select -6 time zone and try to correlate data,
Yeah.
there'd be nothing there. I actually had to select -5 time zone.
Sounds like a summertime something going on, or maybe in the way. So that's a plain match. So the system doesn't try to figure out, as you know, I mean, it's a browser application. So the browser will just say, hey, this guy's here, and that's what I'm going to use. It's pretty tedious to convince the browser that they're acting in a different time zone. So what we do is literally add or subtract from the query time whatever you decide is the difference between UTC and where you are. It's a little bit up to the user to make sure this is actually, working. So we cannot keep, summertime and not.
Right. So, yeah, what I was thinking is there may be a conflict with the local machine time.
Yes. Well, that's what we're fighting against. So we're trying to convince your machine that you're not in the time zone that you actually are.
So when you set up a Homer server of 5,
Yep.
You should just set the local machine to UTC as well?
Correct. Always UTC internally. So all of the packets need to make it into the database as UTC, either natively or translated by the capture server, so that it doesn't matter where you are, we can still make sense of all of them. Because, I mean, in many cases, your packets will be captured in different locations. So you will have a server in the US, server in Asia or in Europe, capturing traffic at the same time for the same session. And if those were reporting with the local time, you understand it would be a total mess to even try and make sense of it. So we convert always everything to UTC based on where the traffic is coming from. So when you look up a session, it doesn't matter if it was captured half in Asia, half in the US, it will still make sense inside of Homer in terms of flow. And by the way, keeping the capture servers synchronized is incredibly important when you go and do detailed.
So that may be an add-on to the documentation, make sure your local machine you're deploying is set for UTC, not your local time.
Yes, I think it's in the wiki, but yeah, we should make it more obvious or more, frontline.
I probably skipped over it.
Point taken. Thank you. Okay, the overhead of using the module. It really depends what you're capturing and how. So by default, the integrated capture agents have a lower overhead because they don't do the job twice. So they feed the packets directly from the car and they just mirror them out. So the overhead is mostly in networking terms. So of course, you're now forking almost all of the packets with encapsulation. So you're basically going to have twice as much traffic, half in the direction of the collector. That's most of the overhead. In terms of performance, if you only do signaling, I would say it should sit below a 5% change from not having a sniffer at most. Sorry? Well, if you want to add RTP and all of the stuff, it's quite of a different deal. If you let me put it this way. If you work, again, with the data that the system already has, so in this case, it could be RTCP, for instance, so your media server already knows how this session is doing because it's handling. If we feed this data, then of course it's very inexpensive to do it, and Homer can do everything else. If we actually need to monitor RTP, so if you don't have any means of just determining the quality from your media server, then yes, it's a much more expensive task. Depending on how many sessions you have, it might cost you an entire dedicated host just to do that kind of analytics. It really depends on the amount of traffic you have and if you go and sniff it again, or if you can extrapolate it from a system that's already doing the job. So that's the big divide between the two ways of doing it, and it determines, of course, how much capacity you're going to need to squeeze out of a system to be able to do it. Normally, the dedicated capture agent that does RTP on a single box, so the average 2-4 core, can do up to probably 20,000 sessions or something like this of media analytics without sweating it here.
More questions?
Well, we have a demo, we have a booth where we display much more of this. You can play with those analytics, you can come click around, or maybe we can talk about your specific case. So we will be happy to see you there. If you already use Homer, we also have a t-shirt waiting for you, so please pass by.
How about a big round of applause, please, for Lorenzo?
Thanks.